So welcome guys for today's lesson. Today we are going to tackle this continuous beam, mostly for first year in technical colleges and also for first year in technical universities. And I've realized that most of the students are having difficulties in tackling these particular questions, and today I really want to show you the quickest method of tackling it. And this is not hard, it is just a simple thing as ABC. It's really easy for you. So it's about calculating this is my question. So the first part is asking about calculating the reactions A and B, and then the second part is saying about calculating the shear forces and maximum bending moment, I think. And then the third part is also about sketching the shear force and bending moment diagram. So we're going to start. We hope you enjoy this lesson, and I'm going to tackle the first part. I don't think, yeah, I want to use at least 30 minutes to see if I can be able to complete, or less than, let's say 25 minutes. Okay, let's start. So first part, it's calculating reactions. So we're going to start from calculating for reaction A, taking moments about B. When you're saying taking moment about B, we are going to calculate for reaction A, but taking moment about B means B will be our reference point. So class, let's go. So the reaction A will be okay, taking moment about B. So we are having the reaction A times 8, our distance, we equate to, this is our reference, remember. So we have the UDL here, multiply by 4 the distance, multiply by 4/2. This 4/2 means that to make it a point load, that's where, because this UDL, the maximum load will act at the center, that's why we are making it center. So we plus, so this we have to put bracket, plus 50 multiplied by this, and remember this is our reference point, so it's 50 multiplied by this distance, 2 plus 4, 6. So it's 50 times 6. Let's key on our calculator. This 2 plus 4, 4 plus 2 times 20. So it's 120. No, I think this is a times, this is a multiplication. So it's 4 times 2 times 20. It's 160. Sorry. Plus this one, 50 times 6 is 300. And this we have 8. Reaction A is equals to plus 160 is equals to 460. So 8 reaction A is equals to 460. You divide by 8, you divide by 8, you get that reaction A is equals to 57.5 kilonewtons. Together, the kilonewtons is because it's a force, it's not a moment, it's a force, it's an upward force. Now for reaction B, so we'll taking moment about A. Taking moment about A, calculating for reaction B. So we'll have reaction B multiply by 8, we equate to, so A will be a reference point, so we'll take 50 multiplied by this distance, plus, now here is the problem, here is where the problems come from. So you must know how to deal with this load that's not extended to here, so you must add this distance. So it's 20 multiplied by 4 over 2 plus the remaining distance, which is 4. And also you must know how to key in this on calculator. You first key in this 4 plus this, and you multiply to this. It's 4 divided by 2, which is 2, plus 4 times 4 times 20. You see, that's how you go about it. Plus this 100 is equals to 8, reaction B. We together, so that's it's 8. Reaction B is equals to, it's for 8 plus 100, that's 580. You divide by 8, so reaction B will be plus 100 divided by 8, so will be 72.5 kilonewton. Although there is another alternative, because when you are in exam and you really need to hurry up, you are running against time, you have another alternative. So you don't have to go all this way. After calculating reaction A, you need to use this. Upward loads is equals to downward loads. Upward loads are reaction A plus reaction B, and downward load are this load, point load 50, plus this load 20. We make it point load times 4. Together we get, it's 20 times 4, that's 80. No, it's 20 times 4 plus 50, that's 130. And we have reaction A, obvious. Reaction A, we have gotten 57.2.5, I mean, plus reaction B is equals to 130. So for reaction B, we'll get 130 minus 57.5, which is, let's prove if we are right. Yeah, of course we are. It's 72.5. So you just look and see which the simplest method you need to use, and instead of going to these, because you can get sometimes continuous beams that's carrying many loads, and maybe it can bring confusion. So you have to go to the simplest way, at least to save on time, and also for you can be active in your mind. So after that, so we know the reaction A is 57.5 kilonewton, and reaction B is 72.5 kilonewton. Now we need to calculate the shear forces. To calculating the shear forces and bending moments. Oh, sorry, my camera is sorry. Okay, so for this we have to calculate, so we need to know how to calculate this. So for this beam, we just need to have a beam so that we can go step by step and be able to calculate the shear forces. So shear forces at A, just left. So we start with shear force at A, just this at A, just this is left, okay, is 0 because we don't have any load at left. And then shear force at A, just right, we have reaction A, which is 52.5 kilonewtons. Is it 52.5? Reaction A 57, I mean, I'm sorry, 57.5 kilonewton. Then we go to point. Let's call this point. Let's call this point, because we have C. Let's call this point C and this point D. Are we together? Okay. So shear force at C just right is equals to C just right. It will remain reaction A. Sorry, let me take a book here. I hope you guys are seeing. Let me take this one. I hope you guys are seeing. Okay, let me just put this way. Yeah, that way. Yeah, good. So reaction, we are reaction C just left. Okay, just left. It will be reaction A, which is 52.7, because there is a no load there. So at C just right, we'll have this 57.5 kilonewton minus, now this load we are minusing because this load is acting downwards, so minus 50, which is we get 7.5 kilonewton. Remember, when you're reaching here, we must get a 0 in order to know that our beam have balance. If we don't get a 0 here, we will know that we have already messed somewhere. So let's continue. So shear force at, we at point D now. Point D just left is equals to, now this one left mean it's here, you have not come here, so it's 7.5 kilonewton, remain that one. So at D just right is equals to 7 minus 7.5 kilonewton minus, now this load we have to make it point load, so it's 20 times 4, which is equals to 20 times 4. 20 times 4, we have 80. Then we have to say 7.5 minus answer. We have to get minus 72.5 kilonewton. That's shear force at D, just right. Now we go at B. So shear force at B just left, we get to be negative 72.5 kilonewton. So shear force at B just right, we get negative 72.5. Just be here right mean there's no loads there. So just left, we have this reaction B, and of which is the upward loads is a positive. Always remember the upward loads are positive, so is a positive. We have to plus 72.5, of which we get 0. Now we are on right track. Now we are going to sketch this shear force diagram, because, and yeah, so for the bending moment diagram I'll be doing it in another part, and I will be uploading the same. So we have to calculate. I don't have a ruler, I'm sorry, I'll be using my pencil here. So let us draw this. God, my camera. So we have to copy whatever is up there, say A, C, D, and B. So here we have just to use what we have just calculated here. So reaction A, God. Yeah, so reaction A just right, we have 0. Just left of A, we have reaction. We have 50 to 57.5. So let's say 57 is somewhere here. So it's 57.5 kilonewton. At C, now we are at C. At C just left, it's just remain that way, so it will be here. C just right, C just right, it will be 7.5. So it will come downwards. Let's say 7.5 is some here. 7.5 kilonewton. So at G, at D just left, D just left, so we D, it's just remained that, so it's 7.5. D just right, we'll get negative 72. Let's say negative, this is 57, so 72 negative will be somewhere here. It is negative 72.5. Then at B just left, we remain that, and just right will be 0. So this stuff will be looking this way. So it will be looking this way, that way. You have to, now you join the dots. It is just easy, but you have to do more practice for you to be moving more faster. Okay, now we have to shade. Remember, this is positive.